Okay, YouTube, in this video we're going to be introducing the concept of the binomial theorem, which really, in essence, is a convenient way to expand a binomial to some power here. So we'd say it's expansion of a binomial to a power. And basically, what we could say is it's generalized in this form right here. Now, one thing I can tell you is everybody that I've showed this to gets really intimidated at first. And so let's recognize what this is. First of all, it's the sum of the terms of a sequence defined by this rule. That's what this is right here. And so this part right here is our rule. And what we have here is starting at the 0th term and going up to the nth term, where n, we're going to list a few things here. We say n is the power on our binomial. That's the power we're raising it to. We're going to go up to that value right there, starting at the 0th value. So that being said, all this is really is a sum, and this is in general explaining what we get here. So the first thing we want to recognize is in this sum that when we expand these things, by the way, when I say an expansion, what I really mean is, for instance here, x plus y to the n, if we had x plus y to the 4th, what I mean is this is the expansion right here. You can see that this is just the sum of 1, 2, 3, 4, 5 terms in some sequence. Okay, so this is some finite sum that we're finding here. But basically, we're just generalizing it in this way. And so important things to recognize. First one is this n, well, I'll read it as NCR. That's how we would read it. NCR, n choose R. So we're going to write that down. N choose R. We're going to refer to this as a combination here fairly soon. But we say n choosing R with this little subscript here on the C. This is known as our binomial coefficient. So what I want you to recognize is this NCR that we're going to focus on in this video. Really, let's label this here. Let me get a different color. Right out in front, let's put a box around this. It says n choose R. This is our binomial coefficient. And so one little message you see that I've written here is this. I thought you said the binomial coefficients were Pascal's triangle. And so here's the interesting thing about it. All of these binomial coefficients that you see here are equal to Pascal's triangle. That is to say that if we did 0 choose 0, we would get 1. If we did 1 choose 0, we would get 1. If we did 1 choose 1, we would get 1. And so all of these values on the left and right are equivalent, so to say. So what I want you to see here is this. In front of all of these is this n. Remember, n is the power on our binomial. And so since n is the power of our binomial here, remember in the last video I said when we raise something to the 0, we just get a coefficient of 1. When we raise something to the 1, like x plus y, we had x plus 1 to the 1, we get 1x plus 1. And so these are the coefficients if we raise it to the first power. So we have second, third, fourth, and fifth powers here, and we could keep going. But you can see how this applies here. We say when n is 0 here, n is 1, n is 2, n is 3, and so on and so forth. You can see how these are all of the coefficients of something that you've raised to the 4th power. And so we can see that here with n being 4 on each of these. And then this 0, 1, 2, 3, 4, those represent kind of like the term numbers. Now, loosely speaking, because really our first term here in the sequence starts with 0, which is a weird thing. It's kind of odd, I'll admit it. But basically, you could see how this is just some sequence here where we're plugging in from 0 to 4, and that's what this says right here, from 0 up to the power. We're going to add all of those terms together, and this is what you would get for your coefficients. So Pascal's triangle really is our binomial coefficients here, and the nice thing about it is n is the power we're raising it to. Now R, if we were to take an examination of R, the first thing I'll tell you is this. On every single term in our expansion, we're going to have an x to the n minus r, y to the r. And that also is, somewhat confusing. So let's go ahead and confront this here. If we were to look at this in general, we say, well, let's plug in 0 for r. What we're going to get is n choose 0, and then we're going to get x to the n minus 0 for r, y to the 0. So if we simplify this, n choose 0, I'll just go ahead and help you out here. Anything choose 0, all of these on our triangle here are all 1. So I'm going to write a 1 here for this. 1 times x to the nth, y to the 0, which is really just x to the nth in our expansion here. And y to the 0 is 1, this is 1. So our next term in the expansion would be n choosing 1. But that's no matter. In terms of what we get for our variables here, we'd have n minus 1 y to the 1, because our r value now is 1 that we're plugging in here, and here. So what you see basically is this. We get n choose 1, which it doesn't really matter that it's n, but you get n. But we get x to the n minus 1. Sorry for my phone there. We get y to the 1. But basically, you could see how as this pattern keeps going, we're going to get n choose 2, x to the n minus 2, y to the 2. And this is going to just keep going all the way down to the last term, which is going to be n choosing n, plus now x to the n minus n. This is the important one, times y to the n, when we plug in an n there. And so x to the n minus n is 0. I'm going to rewrite this, just this one term here. By the way, n choose n, not that it matters much, but that's a 1. We say times x to the 0, which is 1, okay, times y to the n. We get really y to the n. So basically, when we do this expansion, what you're going to see here is whatever you have in for your x and whatever you have in for your y, and these just represent loosely our whatever the first term and the second term in our binomial is. What you're going to see is in this expansion that the first term x, look at all of these instances of x. In the first term, x has all of the n power that we're raising this to. And as we go to the right, look what happens. N is decreasing in power by 1 each time. So it's n minus 1, n minus 2, n minus 3, all the way down to n minus n, where x has none of this power left. The first term basically starts with all the power, and as we go from left to right, it gradually decreases 1 in power. Now our second term, y, look at this. Y started with none of the power, but as we go from left to right, the second term in this expansion here, in our binomial, gains in power 1 each time. It's 1, it's 2, it's 3, it's 4, all the way up to n. So when we do our expansions, what we're going to see is that our two terms here, when we raise it to the nth power, I mean it being the binomial here, we're going to see that really it's just these two terms times each other all the time, x times y, x times y, x times y, x times y, where x starts with all the power, y starts with none of it, and then there's gradual trade-off of the power. So what I mean by that is, we'll just go ahead and take a look at an example here where we're going to expand a couple binomials here. So stick with me. We're going to write the binomial expansion of something that looks like this. So before we begin, let's go ahead and take a look at the coefficient of this expansion. Now one thing needs to be for sure. This is what we're going to refer to as a combination. A combination, okay, says if you have n total things and you want to rearrange r of them, this is how many ways you could do it. Now in a counting sense, that's what that means. In our sense, what we know is that this is the coefficient of our term in the expansion. So what we're going to define this as is n choosing r is n factorial over r factorial n minus r factorial. So one thing we want to make sure we note here is this, and this is just kind of a quick side note, but we say r plus n minus r is equal to, look at the r's cancel and you get n. And so this is like the total power that we're raising our binomial to in the first place. So r and n minus r, they always add up to, basically add up to n, which is the total power. So we're going to say this here. These always add up to be the top number here, n. It just always happens. So we have a calculator command here. We're going to take a look at how you do this in the calculator. But what we're going to say is this. This n choose r can be also written as this. We could say n choosing r is the same thing as n choosing r. And so with respect to this, let's go ahead and take a look at a couple of examples, and then we'll look at it in the calculator, and then we'll expand this binomial. But in this first instance here, we're going to see n is equal to 8 and r is equal to 2. So in this case, we get n factorial, 8 factorial, and this is going to be over r factorial, so our r value is 2 factorial. The nice thing about it, though, is this other number adds up with the first number here to be the top number, the 8. So I know that I'm going to get 6 factorial here, and really, if I'm showing my work, I will on this first one. We get really 8 minus 2 factorial. But basically, we get 8 factorial over 2 factorial, 6 factorial. And so with respect to simplifying this, we're going to say this is 8 times 7 times the bigger of the 2 factorials in the bottom there, because what we're going to do is this. We're going to cancel out the 6 factorials, and we get left with 8 times 7 all over 2 times 1. Or in other words, if we reduce these, we get 4 times 7, we get 28. And so 28 would be the value of this 8 choose 2. Now 10 choosing 3, the same thing here. We're going to say n is 10. We'd say 3 on the bottom here is our r, so this must be a 7. Going a little bit more quickly this time, I'll write it down here. We'd say this is 10 factorial over 3 factorial, and the bigger the 2 factorials, oops, not 10 factorial, but 10 times 9 times 8 times 7 factorial. and then we'd say we adopted the 7 factorial because the bottom, that was the biggest factorial down there. We can cancel those out. So really we get 10 times 9 times 8 all over 3 times 2 times 1, where a 3 and our 9, that would make our 9 a 3 here, and our 2 and our 10, I guess, make this a 5. So 5 times 3, 15, and 15 times 8, this would be 30 times 4 is 120. And so in terms of evaluating this on a calculator, here's where we're going to want to open up our calculators. So with respect to our calculators, in our math menu here, we're going to see that we have a math button on the left here. I'm going to adjust my contrast. Go ahead and go to your math menu. But basically, and actually before we go there, let's do this first. Since we're going to evaluate these same two, we're going to write 8, choose 2. You're going to write 8 first, but then we'll go to math. And what we're going to do is cycle over here to this probability menu. And where it says NCR, we'll just scroll right down to that. We're going to type in 2. And so we get 2. And 8 choose 2 says we get 28, which is exactly what we got when we evaluated this by hand. And also this 120 right here, this 10 choose 3, we could also say 10 math, go over to probability here, scroll down to combinations, and we'll go to 3 here, and we get 120. Very nice. So with respect to finding the binomials, we should be good with this now. So in this next video, we're going to look at how we can expand this binomial using what we know about combinations and the properties of expansion with respect to our terms. Cheers.